All right. So determining the roots of an equation. So now we're going to start to take what we learned from last unit and what we learned from factoring and put them together. Okay, and what do they mean? So let's look at this little investigation. So we want to figure out, okay, what would x have to be to make x minus 3 equals 0 true? 3. It's only true if x is 3, because then 3 minus 3 is 0. There we go. Okay, what would x have to be here? Negative 1. Because negative 1 plus 1 equals 0. Now, if it says the product of these two numbers, the product, x minus 3 times x plus 1, it has to equal 0. It's true if, well, only one of them has to be 0, right, to make a product 0. 0 times any number. So if x was, what about the first one? What would make this 0? 3 or negative 1. Because negative 1 and 1. So those are going to be the x-intercepts. Bingo. Because the x-intercepts are when y equals 0. When our equation is equal to 0. So that's what it's going to be, our x-intercepts. So next guy, does it matter if there's a 2 in front? Not really. You just get 2 times 0 times a number would still be 0. So even if we just look at the inside of the brackets in the factored form, it doesn't matter if there's an a value in front. So again, this could be 0 as long as x was 3 or negative 1. How about this situation? Well, first I'll look in the brackets. What would make that 0? This in the brackets here. Negative 1. So if x equals negative 1 or if x equals, how about this guy? 0, just 0 because it's by itself. And 2 times 0 would be 0. So x equals negative 1 or x equals 0. So basically what we're doing today, we're taking our factoring skills and we're figuring out the zeros or the x-intercepts, the zeros of the equation. So if you have a highlighter, this would be a good line to highlight. So some of you, my highlighters are starting to dwindle down. Okay. I know. Okay, so the product of the multiple factors is equal to 0. If the product is equal to 0, then at least one of the factors must be 0. Right? If the product's going to be equal to 0, then at least one of them is equal to 0. So if a times b equals 0, then either a equals 0 or b has to be 0. One of them has to be 0 to make it equal to 0. Okay, so complete the following. So if we have a factor, what if it looks more complex like that? We still need to figure it's 0. So what we do is individually set it equal to 0 and solve for x. So in the first, we have a product between 2x plus 1 and 3x minus 7. So for 2x plus 1, we set that equal to 0, and we're going to solve for x. What would your first step be? Take away 1, and then divide by 2. So x equals negative half, or let's do the next one. What would be our first step? Add 7. So 3x equals 7. Yeah, get x by itself. Divide by 3. So x equals 7 over 3. So remember, over 3. There we go. Thank you. So notice the relationship between the sign, and what x equals. So notice here, in the first one, our sign was 2x plus 1. It was positive, and our 0 had to be negative. In the second one, we had 3x minus 7. Notice that our x equals a positive, opposite sign. Also, a little shortcut, the second over the first, so 1 over 2. So negative 1 over 2, negative, or so this positive, opposite sign, 7 over 3. Yeah. So we can verify that it actually equals 0 by plugging it in. We're going to skip the verification. Let's go on to the next page. It's a miracle. I skipped something, yes. Okay, so an equation is solved by stating the values of the variable which makes the left side and right side equal. Okay, blah, 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 blah. let's go down to the box. Solve the equation x minus 2 times x minus 4 equals 0. So how do we solve it? We set each one individually to 0, and then solve for what the x would be. So the solution to this would be x equals 2 and x equals 4, because that would be the solution that would make the product 0. Either if x was 2, it would be 0, or if x was 4, it would be 0. Why? Well, if it was 2, it would get 2 minus 0. 2 minus 2, I mean, which is 0. Times whatever the number is, doesn't matter. 0 times anything, 0. Okay, so determine the roots is the same idea. We're solving for what would make it 0, 2 and 4. Those would be the roots, or the x-intercepts. So let's look at this equation. What would be to solve the following equation? So what would x have to be to make this 0? 7 or negative 8. Good. How about, that's it. But what's the key here? What form does it have to be in? Factored form. Has to be factored form. So if it's not in factored form, that's where the work will come in. The next guy, what would be the solution here? X equals negative 10 or 0. When an x by itself, we just put 0. Child's play. Hey. Let's solve the next one. 2x minus 5 times 3x plus 2. So each one of these, if we don't know this, if we don't set it to 0. So we'll first set 2x minus 5 to 0. Let's solve for x. First step, plus 5. So 2x equals 5, then divide by 2. Notice how no, because we want to make this 0. 2 times 3 would be 6. 6 minus 5. Right? So the thing here is 2 times 5 over 2 is going to be just 5, and 5 minus 5 is 0. So that's why it's always opposite sign, second over first. The short way? Okay, what was the sign of this one going to be? Negative, second over first. 2 over 3. Opposite sign. Right? Because if we solve, so if I plug this in, 3 times negative 2 over 3 plus 2, well, this becomes just negative 2 plus 2, or 0. So it has to be opposite sign, so that it equals 0.
Do you have to get both of them to get the answer right?
Yeah, you need both to get the answer right. So that's our solution. X equals negative 2/3 and 5 over 2. There's two. So in a quadratic, there's 2 possible solutions. In linear, what we did last year, there was always 1. If you did intersections and stuff, because we're intersecting with y equals 0 with the x-axis here. Okay, next page. That's how fast it's going. Yeah, we just one more page and then we're done. This lesson, yeah. Okay, so if it's not in factored form, we need to get it into factored form. So this guy, we just do what we did. Exactly. And we know how to do that. First question we ask ourselves is there a greatest common factor? The answer is no, because is it simple or complex? Simple, because there's nothing in front of the x squared. So we want two numbers that multiply to 20 and adds to negative 9. So if we're multiplying to a positive and adding to a negative, they have to be both negative. Does anyone know from the top of their head? Negative 5, negative 4. Good job. Okay, so x minus 5, x minus 4. Okay, guys. Back on track. Okay, so we set each one of these to 0. We set x minus 5 to 0 and x minus 4 to 0. So what would make these zeros? If x was 5, positive 5 or positive 4. So the roots are 5 and 4. Why? Same stuff. So we just look at this, right? We just need to look at that. So what would make this guy 0? 5. What would make this guy 0? 4. Okay, so let's try a couple together. So we're going to Look at the first guy. Simple or complex? Simple. Front seat. You're going to grow to love math. That attitude. This is now your seat. Yes. Yes, you can, and you're going to. You can. You have a choice. And if you can't, then there's other options. And it's out there. Okay. So, okay. Two numbers that multiply to negative 14 add to negative 5. Okay, we have to multiply to a negative. So 7 and 2, which one's negative? Want to add to a negative. The larger one's negative because we want to add to a negative. If we're adding to a positive, then the bigger number's positive. If we're adding to a negative, the bigger number's negative. Okay. So how would we write this in factored form? No. Just x minus 7, x plus 2 equals 0. Just simple. We didn't have to break it apart. It's simple. Okay, so our solutions. 7, x equals 7, not 2, negative 2. Okay, next guy. What does that look like? It's not, well, okay, difference of squares. Two terms separated by minus, and we can square root both of them. Remember difference of squares? So square root of 4x squared is 2x. 2x and 2x. Square root of 25. 5 and 5. One's going to be positive. One's going to be negative. Equals 0. So x is going to be equal to. So what would make that 0? 0. So, ooh, there's a number in front. Negative 5 over 2 for the first. Second over first, opposite sign. And then positive 5 over 2. And if you wanted to get fancy, you could write x equals plus or minus 5 over 2. Okay, next way. Looking at this, two terms. Definitely not a difference of squares. What's the first thing we ask ourselves? Greatest common factor. 10 and x. Okay, Jesse, you writing this down? You writing it down? No, write it down in your book, please. Okay, so 10x. Remember when we factor something out, it goes in front. What's 10x squared divided by 10x? X. And then minus 9 equals 0. So what would make this 0? If x was 0, so if it's by itself, 0, or positive 9. Okay. Next guy. First question we ask ourselves, is there a? What's different about this one? 90 doesn't have an x. So this time we're only factoring out 10, x squared minus 9, but we can take x squared minus 9 one step further. We can square root 9. It's a difference of squares. It's 3. So, and square root of x squared, x. So we get x and x, 3 and 3, and what are the signs? Plus and minus, because the middle term cancels. You with us, team?
Bro.
Okay, what would make this 0 if x was -3 or +3? Okay, almost done. I didn't. Okay, when solving a quadratic equation by factoring, the quadratic equation must have all the terms on one side of the equation and 0 on the other side. Okay, so it is usually easier to factor if the coefficient of x squared is positive. So a tip. So here we don't have 5, right? We don't have 0, I mean. We have a 5. So the first thing we want to do is actually expand this. So let's expand this guy first. X times x minus 4x equals 5. Now we still need one side equal.
Oh, and then you do -5, and then you have, and then you make this work, and then you go all right?
Okay. Okay, so now we want to get 0, this side 0. How do we make 5 0? -5. Subtract 5. So now we get x squared. Simple or complex? Simple. So two numbers and multiply to -5. Okay, Dean, this one's for you. And adds to -4. This is for Dean. Shh. Okay, so how can we multiply to -5? Tell me the two ways. 5 times -1 or +1 and -5. Which one of these, Dean, adds to -4? -5 and 1. Okay, so because this is simple, tell me all that I need to do here, or do you want to write it down? Okay, no? Okay, it's simple. Factor this. We got the two numbers.
Hate being called out. I freeze under pressure, okay?
Why are you doing this?
No, you're wrong. No, yep, you can write it. There you go.
What is that?
Yeah. Equals 0. It's an equation. Okay, so what's our solution? X equals 5, x equals -1. Okay, one more question. It's easier if x squared is positive. So we need everything on one side and one side 0. So who are we going to move? Whom are we going to move? The -3x squared. Let's bring them to the other side.
Bring our people over.
Could you just go like right to it?
No, we have to have one side equal to 0. Yeah, could you go just straight to writing this? Yes, absolutely. Okay, you don't have to write +3x squared plus 3x squared. That was more, like now that you guys are getting more confident in your math, I would hope that you would get to that level where you could just do that. No, you don't need to write that. And you don't have to. And there's nothing wrong with that, but it's okay if you don't. Jesse? Is there a greatest common factor? Look at the smallest number. What's the smallest number? 3. Does 3 go into 10 or 13? No. So no greatest common factor. Next, is it simple or complex? Complex. So if it's complex, the number in front of the x squared, we want two numbers that multiply to -30 adds to. Now here's a little hint. 30 and -30 is a little tricky. Because sometimes it's 10 and 3 and sometimes it's 5 and 2. So 15 and 2, sorry, 15 and 2. So we have to think, right? So you have to be careful.
15 and 2.
Negative 15, positive 2? Because we have to multiply to a negative. So 1 is positive, 1's negative. If we did 10 and 3, that adds to negative 7. Right. So it has to be negative 15 and negative 2. Now in complex, what do we have to do? When we factor complex, can we go straight to the brackets? Replace the middle term. So 3x squared. So instead of writing minus 13x, minus 15x plus 2x minus 10. What can we factor out of the first two? 3x, and we're going to be left with x minus, what's 15x divided by 3x? 5. What can we factor out here? 2. X minus 5. And last, okay, so our solutions, x would have to be equal to opposite sign, so negative 2 over 3 and positive 5. Okay, so here's the homework. I've reduced it a bit. Numbers 1 to 4, 5A, C, D, 6, 7, 8, 9A, C. Okay? Yeah. Okay? So you have 50 minutes. 5-0. Lots of time. Okay? If you have questions, ask.